and went through departments and just removed the 40 watts and put in 32 watts. Now, persons weren't understanding because these were good working bulbs. I mean, why are you taking down the bulbs? But then we saw the results and we saw that it's actually wasting money by having them. So we removed all those bulbs, thousands upon thousands of fluorescent tubes rather. And that created another problem in itself, because how do we dispose of that in an environmentally conscious way? And so we implemented environmental measures. We imported a bulb eater from Australia. It's actually called a bulb eater. What it does is just pulverizes the tube and separates the mercury from the glass. And then we could dispose of the glass safely, and we could dispose of the mercury safely. Funny thing though, Jamaica doesn't have a policy for disposal of hazardous waste. So we still have the mercury. And we actually plan to find a way to properly reuse it or dispose it, and then develop that into a policy for national consumption. And that's another thing the university does, From a lot of what I'm showing you now, the value of the data that we have, we collaborate with the government, we try to inform them on their own policies. And that's one way we help in national development. But I must say though, you is not very good at shouting and proclaiming all that it's doing. So sometimes the perception is there that university is not doing enough. But we're in fact doing quite a bit. In terms of the national policy that's being promoted now, we are very heavily involved in that. And we still are involved in a lot of programs that they're doing. Because whenever we talk about something, we're not trying to sell it to you, because we have no interest in that. We research it, we study it, and based on how it operates on the local market. Because how something works here in Jamaica is not the same to work in America. It's not the same. A lot of variables have changed. So it's totally different. So it's good to get experience from home. And that is what we provide with data. And that's one contribution we're able to make. Now, in case of this graph, we look at kilowatt hour. And we decided to choose one of our seasons. And this season will be from September to December, called that first semester of the academic year. If you compare the first semester of academic year with the first semester of previous years, 08, 09, 010, the patterns of usage should be fairly the same because same classes are being taught, etc., etc. Of course, new programs may come on stream, expansion might happen here and there. But what we realize is that one thing you definitely expect to happen is that your kilowatt hour should increase, not decrease. But as a result of the projects that we did, those 11,000 tubes I talk about and the 4,000 ballast and the power factor correction, among other things, motion sensor, etc., we're able to show that we actually saw a reduction in kilowatt. The black one represents 2010. Now, this one is lower because this is the year of Hurricane Gustav. And instead of having 153 days, the entire September to December period was 153 days in billing period. For this particular year, 08, it was 149. There are 3 days when no electricity was supplied. So it impacted this bill, but this should actually be a little higher. And so we saw that there were reductions. Now, speaking from an academic perspective, we're not able to say definitively that it's because or only because of the measures that we implemented why the reduction occurred. But we are absolutely certain that the correlation between the measures we implemented, the proof that we provided, for example, physics I showed you, the reduction, it is consistent with the reduction we're seeing in the overall bill. So we can actually say that to a large part, maybe even 90%, all that we did impacted the kilowatt hour on campus. That's the argument. Now, we are able to defend it with data, and we also showed it for KVA. You notice that for 2010, the KVA actually went down. Now, our kilowatt went down, our KVA went down. So if you run the numbers, JPS School kilowatt hour charges per month, for us, since 2005, moved from $1.64 to as high as $3.39. And fuel and IPP fluctuates, but the average was from $6.51 to as high as $14.82. Now, if you look at those numbers, you realize that no matter what, the fact that the unit costs for both kilowatt and kVA have increased for every year, it means that for 2010, being the most current year, it should actually be higher than all the previous years. But what has happened is that because of the measures, or to a very large part because of the measures, we actually experience reductions in KVA. It's now 5,169, down from as high as 5,006, and it's coming from as low as 5,000. So what we're saying is that we're almost back at 2005 levels. Now, persons who come on campus between 2005 and now would know that a lot of stuff have changed. Just looking alone, you know that a lot of new buildings came up, lots of stuff have changed. So how on earth can we say that we're using energy at the same level that we were? Mostly because of energy conservation efficiency. That's the impact it had. And because of the impact it also has on kilowatt hour, now we just start to say, how much is that really in dollar terms? And running the numbers as how JPSCO would also calculate it, where I try to simplify their calculation. This is a simplified version because it's rather complex. The unit KVA, I'm dealing with averages in my case because I'm looking at the semester. So it's a unit KVA times the average KVA for that semester, and same thing for kilowatt, same thing for fuel and IPP. Of course, if there are other variables that you would add to get a proper bill, and that would be like the foreign exchange, and if there are any other charge, for example, the customer charge, etc. But just the basics of it is that the demand charge being KVA, the energy consumption charge being kilowatt hour, and the fuel and IPP charge. When we worked those out for the numbers I just showed you, you found that using 2008 as a base year, I didn't go as far back as 05. What we realized is that for 2009, we actually increased over 2008 by 139 kVA. Now, this is the type of consistency we'd expect. Now, I must say that in 2009, we started the projects already, but it wasn't as widespread as yet. It takes a while to install 11,000 tubes. It takes a while, and that was just 11,000 4-foot for offices, lecture theaters. And we install another 3,000 and odd 2-foot for the halls of residence, because the halls primarily use 2-foots. So we're talking about 6 halls of residence, several buildings, lecture theaters and stuff. Lots of work. And that is why we needed, dedicated management as well for that. And so based on all of that, in spite of all those measures, we were about 40% into the project at the time. 2009 values increased by 139 kVA. Excuse me. And when you work that out, that turns out to be, we spent an extra $2.3 million for 2009. Now, I didn't put UE bill here or anything, but you can easily calculate it based on the levels I'm showing you. But just to give you a ballpark figure, since the semester that's ended, our average monthly bill is about 39 million per month. There was a time when our average bill was 47 million per month. Per month, average bill. So we're talking about a lot of money. To be filing $40 million every month is not, well, it's difficult. To say it's not easy, it's difficult. But in 2010, we realized that a total reversal occurred. We actually used 441 less kVA. No, that is very significant, I'll give you a simple idea. Right now on campus, the new Faculty of Law, another part of our expansion, it's it's 3 stories, double. Two large buildings, 3 stories each. I think the cooling capacity is in the region of some 300 and something tons or more, and many other things. But we're involved from the beginning, and we're able to ensure that everything was put in. Even the very position of the building was taken into consideration to reduce heat loading, sun shading, but everything we did it as best we could based on what we could afford. And that building has added 162 kVA to the campus. Now, that's a very large building, and that's just 162 kVA. So when you talk about 441 kVA, we're talking several large buildings. We're able to eliminate that just by implementing those measures. Now, what that translated in terms of savings is that every month for September, since September, the semester that just ended, we are able to save $3.6 million. And that's a fact based on the rates and the numbers. But when you actually look at the actual bill, JPSCO had increases last year, and so the overall impact on the bill was that we're only seeing about $1.5 million less. But again, that's still very significant.